Bir de bilmiyorsun yani pardon. For example, okay. Exist type in for number 4. So here writing dual vectors as two vectors. This is the section of the book which I didn't cover, but I gave as an exercise on this sheet. Let me just explain you what's going on. So is a vector space or usual, and suppose we are given a base. Let's say V1, V2, okay, Vn a basis, and we have two basis elements. Okay, so we have a vector space and we have a basis, let's say, and dual basis. You would like to write those vectors, co-vectors, using wedge of these vectors. I mean, is a okay. Here is what we are going to do. So, observation is the following. Observation. Mesela let's consider V1. V1 start. On V1, this is 1, not 0. And on the other vectors, V1 start, V2 is 0, and V1 start, Vn is 0, right? There is another object which does exactly the same. What is that? Now consider this. Consider the n-1 vector W, which is just this element. V2, wedge V3, wedge Vn. Okay. Yes. Şuna bakalım. Ya da şöyle diyeyim. Okay. Now, V1 or okay, V2 şöyle diyeyim. V1 ve W1 is just V1 ve V2 ve Vn, and that's not zero. If these are independent, this is a non-zero vector. But V2 wedge, this one, V2 wedge, V2 Vn, this is zero because the first two vectors are the same. And similarly, Vn wedge this, Vn wedge V2 wedge Vn. This is also zero because Vn is in this product. Right? If we have two vectors in this product, the same vectors in the product, then you get zero, right? If a vector is repeated in wedge product, it is zero. So you see this similarity between this n-1 vector and the dual vector. And observation is the following. Observation is the following. If let's say U is any vector in B. Then, of course, I can write the U as well. In this basis, let's say A1, B1, A2, B2, up to AN, DN. Now, what is D1 star U? Well, D1 star on U, on V2, it will give us 0 because, D1 star gives us 0 here, 0 here, 0 here. It will just give 1 on D1, and the coefficient is just, so D1 star, A1, D1, AN, DN, right? It will give 0 on this element, on this element, and on this element, and on this one it will give me 1, and the coefficient is just A1, so this is just A1, right? And let's look at the following. U tensor W. What is this? U is just A1, B1, right? A2, B2, AN, BN, tensor W. W is just B2, B3, BN. What is this tensor product? Well, this is just, okay, I have first term A1, B1, so it will give me A1, B1, and then B2 up to Bn, and then plus I have A2, B2, wedge product B2, it is 0. The next one, A3, B3, wedge product with this, it will give me 0 because I have B3 here. So the rest will give me just 0. So it's just 0. So what we see is that this product and this thing are almost the same. This gives me A1, this gives me not A1, but A1 times the volume element, right? B1, B2, Bn. So the conclusion is what? Hence, B1 star, no, not B1 star, U wedge W is just what? B1 star of U wedge W. Okay, so yes. Efendim? Bir eksik kalmıyor mu derken?
İmanslardan sadece AB geliyor ve W'da çeviriyor. Biraz sonuçta verecek.
Yok değil. Yani bak bu çarpım B no, U wedge W is A1 times B1, B2, Bn. Ha şunu diyorsun. Özür dilerim. Tamam. Şunu söyledim. Tamam. This is just a number, right? I'm sorry. B1 wedge B2 Bn. Tamam. Bu ne veriyor bize? Şurada bu tabii ki W nedir? Yani U W is just B2 Bn. Here B1 star U B1 B2 Bn. So if you want to compute B1 star, you just need to actually take wedge product of U with the rest of the vectors, right? Similarly, for example, what is the 2 star of U? Well, V2, no, V1, V2, Vn. Here we will have what? Okay. U which we should have V1 which I have to skip V2, so V3 and Vn. But we have to be careful. Why is that? Because here this is just, let's say, A1 V1, A2 V2, right? An Vn, and when you multiply with this, this will give me 0, this will give me 0, only this one won't give 0, but that gives me what? That gives me, so this is equal to what? A2, and then V2 times this figure, like V2, V1, V3, Vn, and this is just, if I want to write it in this form, it should be minus N2 times V1, V2, Vn. So this gives me what? This gives me the following. So these are equal, but then this thing is just of course, this should be A2, right? This should be A2 because V2 star applied to this guy should give me A2, but it is not, it is minus A2 here. They are not the same. The reason is that actually these are not equal. I have to put a minus sign here. Okay? Minus sign here. And then these are equal. Yani, for the first vector, this is okay, but for the second covector, you have to put a minus sign because you should make a transposition. For V3, it will be again plus, but for V4, it will be minus and so on. Okay, now let's go back to this problem. Our problem was this. So example. So we are given a basis V1, 1, 2, 3, V2 minus 2, 4, 0, and V3 is 3 minus 1, 5. Okay, now what is V1 star? V1 star will be what? V1 star on U, it should be what? V1, V2, V3 should be just U which V2, V3. Okay. Yani ne yapabiliriz? Okay, let me just do the following. Let's say this is ABC. Okay. ABC. V1 is what? V1 is just 1, 2, 3. I can write this as follows: AE1, BE2, CE3. This is just E1 plus 2, E2 plus 3, E3. What about V2? Minus 2, 4, 0. So this is minus 2, E2 plus 4, E3. And V3 is just 3 minus 1 and 5. So 3E1 minus E2 plus 5 E3. Okay. To determine this digit, my aim is to determine this. I have to compute this determinant and this determinant, right? Two determinants. Let's do that. Şundan başlayayım. V1 wedge, V2 wedge, V3. So this is E1 plus 2E2 plus 3E3, which minus 2E2 plus 4E3, which 3E1 minus E2 plus 5E3. O da zor seçmişim biraz ama.
Hocam birinci açsak mı böyle?
Efendim?
B2'de yanlış
Eksi 2
E1.
E1.
Oradan doğru.
Ha, burası E1.
Yan tarafta
Bu da E2. Tamam. E1, E2.
belki birinci yazsak.
Efendim?
Mesela birinciyi açarak gitse.
Birinciyi aşağı etsek.
Yok, birinciyi açarak gitse mesela.
Ha, tamam.
E1 işte. E1
Evet.
işte yani.
E1, buradan E1'den if I start with E1, I cannot take this one, I will take this one. And I have to take this one. Ne oldu o zaman? 1, 4, 5, 20, right? E1, wedge, E2, wedge, E3. All right. Plus E2, right? I am done with this term. What about this one? E2. If I take E2, I cannot take E1. So I have to take E1, 2 minus 2. And I have to take 5 here. And then I have E2, wedge E1, wedge E3, right? So this is my plus minus 20, but if I interchange this two, I will pick up another minus 1. So it will be plus. So I will get this. What else? It and if I have this, okay, so I have two more terms. Okay, let me just do it here then. So let me rewrite this. So I have two terms here. 20 of this, 20, another 20, so 40. E1 wedge, E2 wedge, E3. And then plus, I take this one. If I take this one, I have to take this guy. So 3 eksi 2 eksi 6 artı 6. 6 tane nedir? 2 yok. E3, E1, E2 değil mi? To get this one, I have to make two transpositions, right? E1, E2, E3. So, yani bunu iki kere atlatacağım. So, if you make two transpositions, sign doesn't change, so we get this. Plus, last element, I take this one, and then this one, and then I have to take this one. Yani 3, 12, 36 değil mi? 36 tane 3, 2, 1. Ne yapmam lazım? Bu ikisinin yerini değiştireceğim. Yok. Şunu 2 kere atlatacağım. Ondan sonra bu ikisini atlatacağım. 3 transposition. Dolayısıyla eksi. 1, 2, 3. Yok. Oldu mu? Evet. Tamam. Ne oldu? 46 eksi 36 10. So minus plus 10 E1 wedge, E2 wedge, E3. Okay. And then I need to compute also this gadget, right? We need to also compute this gadget. So let's do that. U wedge V2 wedge V3. U is just A E1, B into C E3, which U2 neydi? Eksi 2 E1 artı 4 E2 which 3 exercise olduğu için tabii sayılarla fazla uğraşmadım. İşte bunu sınavda sorarsanız kimse yapamaz. Çünkü bu kadar hesabın içinde illa ki hata yaparsanız ben de sıfırı basarım.
Bana olarak 8 olmalı.
Hesabı kolay olur. Yani bu mesela egzersiz için iyi ama sınav sorusu için kötü çünkü bir sürü hesap var ve illa ki birinde hata yaparsın.
Hocam hata yaparsak bir sıfır basar mısın?
Evet.
Hocam ben çözersek
Ya çünkü o hatayı bulmak çok iyi. Nerede hata yaptınız? O yüzden genelde sıfır basayım.
Ben de lütfen. I can say the answer.
Okay, that would be great.
28 plus 10 minus 10 E1.
Okay. That's very good. Now you just need to compare these two. So you see, if I have 10 E1, E2, E3, which is just this vector, the coefficient would be what? 2A plus B minus C. So this gadget is just 2A plus B minus C, 10 of this. So this is, what was this? V1 star, U, and then V1 wedge, V2 wedge, V3, right? 10 E1, E2, E3 is this gadget. So what is V1 star U then? So V1 star U is just 2A plus B minus C. Evet, onu size bırakıyorum. Yani yapmayacağım ben tabii ki. Tamam mı? Anlaşıldı mı? Zor mu? Evet.
But in the question it says write it as a range product, two range product.
Yeah, I couldn't find another way to express it. But this is what I mean. Yeah. Tamam mı? Bir şey daha yapacaktım. Determinant yapacağım, evet. Okay, let me... bunlar da determinant değil mi? Şeyin determinantını biliyorsunuz değil mi? Example. T, let's say T is an operator, or A hat is an operator from, let's say, R3 to R3, given by A hat X, Y, Z is just, okay, X plus Y minus 2Z, Y minus 3Z, plus 3Z, and then X plus 2Z. X plus Z. So, what is the determinant of A hat? How to find the determinant? Determinant satisfies the following. You just choose any basis, right? Any basis. Well, in this case, of course, since we can choose any basis, why not choose the most, convenient one? E1 1 0 0, E2 0 1 0, E3 0 0 1, and then we do what? We do the following. We know that A cube E1 dash E2 dash E3. This is the linear map, and this is a triple product in the wedge product of R3 with itself 3 times. It is one dimensional, we know this. So therefore, this is just a real number times this gadget. And that real number is defined to be a wedge. E1 wedge, E2 wedge, E3. So all you need to do, just compute this gadget. So let's just do that. Efendim?
And he increased the.
Evet, öyle bir şeyler yapıyor. So what is this gadget? A head of E1 wedge, E2 wedge, E3. This is by definition is the following. You just compute A of E1 and then take wedge with A of E2 and take wedge with A of E3, right? You just need to compute this vectors. So what is A head of E1? 1 0 0. If you plug it, we get 1 0 1. A head of E2 is just 1 1 0. A head of E3 minus 2 3 and 1. So this is just E1 plus E3, which E1 plus E2, which minus 2E1 plus 3E2 plus E3. Okay. O zaman ne çıkar buradan? I can start from this one. So E1 and then I have to take E2 and then E3 here, here. So 1 times E1 dash E2 dash E3 plus başka yok zaten, right? If I take this one, I have to take this one and then I have to take this one, that's it. Now let me start with this one, E3. I can choose this one. If I choose this one, then I need to choose this guy. So 1 1 3 yani 3 tane E3 E1 E2 artı I can choose this one also E3 E2 and then I have to choose this one minus 2 E3 E2 E1. Peki bu da nedir? Okay, now this should jump twice, so it is still plus, right? So this is got 3E1 E3 E3, and here this should jump here, and then this should jump 2 more times. 3 tane. Tane. Öyle de olur. 1 3 değil. Yani sonuçta artı 2 olur. Ne oldu? 1 6 tane. So 6 times E1 makes E2 makes E3. Therefore, the terminal of A is just 6. Tamam mı? Bu ne demek? Bu lineer transformasyon hacmi değil mi? 6 katını çıkartıyor, right? So this linear map multiplies volume by 6. This is a parallel pipette in R3. It is sent to 6 times that gadget. So volume is multiplied by 6. Yes.
Normalde bu şekilde elde edilir mi? Herhangi bir pardon.
Eğitim yani şey mi diyorsun? Matrix düzen. Evet, evet.
Yani bu şekilde çözmek kabul ediyor.
Tabii ki. Of course. We showed that they are equal, right? You can do the following. You can write down matrix representation of A, right? That is the matrix representation of A in this basis, beta to beta. Burada yaptık zaten. 1, 0, 1, right? 1, 1, 0, and minus 2, 3, 1. And determinant is just determinant of this, right? So, determinant of this matrix is just 6. They are the same.
Mesela her beyaz olacak. Mesela şu bir farklı
Hangi base?
mesela
Fark etmez. Hangi base'i kullanırsanız kullanın. Matris farklı çıkar ama determinant değişmez. If you choose a different basis, you get a different matrix representation, of course, but the determinant won't change. Tamam mı? Okay. Bir de size bir determinant sorusu sormuştum. Onu yaptınız mı? Van der Mont matris. Başka bir şey söyleyeceğim. Evet, yani neydi o? 1 x değil mi? Şöyleydi. X kare, x1 n1 1 x2 x2 kare, x2 n1. So 1 xn square, xn n minus 1. So this is n by n matrix, and we are asked to find the determinant of this. Okay, so what is the determinant? Well, observation is the following. Determinant is a polynomial, right? Because what is the determinant? If you use the permutation definition, you just pick elements from each row, but different elements. If you use, you can choose this element from the first row, this element from the second one, this element from the third one. You just multiply them. You do all possible multiplications and then add them up, but you have to be careful. Sometimes you put plus sign, sometimes you put minus sign, depending on the permutation, right? But at the end, you will get a polynomial in x1, x2, x3, xn, right? Because you are just multiplying these gadgets, so you have to obtain a polynomial. Okay, so this is a polynomial. Is a polynomial in x1, xn of degree. How much? What is the degree of this polynomial? Well, each time you have to pick one element from this one, degree 0, and then one element from this, degree 1, and then one element from this, degree 2, degree 3, degree n minus 1, and you multiply them, right? So degree 0 element, degree 1 element, degree 2 element, degree n minus 1 element. If you multiply these elements, this will be the degree. And what is this number? Efendim? Evet, o en eksi 1. Right? So degree n times n minus 1 over 2. So this is a polynomial in these variables, and the degree is n times n minus 1 over 2. Tamam mı? Herkes buraya kadar anladı mı? Çünkü ne yapıyorum? Her seferinde bir satırdan tek bir eleman seçiyorum. Değil mi? Derecesi 0 olan seçtim, 1 olan seçtim, 2 olan, 3 olan, 4 olan, n-1 olan çarpıyorum. Çarpınca dereceleri topluyorsunuz. 0, 1, 2, n-1'e kadar. O zaman toplam derecesi bu. Her bir terimin derecesi bu. So this is a homogeneous polynomial. All the monomials have the same degree. And that degree is this much. Evet.
N-1'de bitiyorsa o zaman toplam form N-1 şartı N-2 olur.
Efendim?
N-1'e kadar topluyoruz ya.
Birden n-1'e kadar topluyorum. n-1 artı n-1 çarpı n-1 artı 1 n bölü 2. Bunu anlattım ama evet. Tamam. Okay, so we are asked to compute this determinant. The first observation is that this determinant is just sum of n factorial terms, and each term is a product of elements from chosen from each row, right? You pick an element from the first row, from the second row, third row, and so on. You multiply them, and then you add them up, putting a minus sign or plus sign, depending on the permutation. So it's a polynomial in these variables, and the total degree of this polynomial will be 1. You will pick one element from here, which is degree 0, and then one element from here, degree 1, and then another element, degree 2, and so on. So the total degree will be just the sum of the degrees of the terms in the product form. So it is just n times n minus 1 over 2. So this is a homogeneous polynomial of degree n times n minus 1 over 2. And then what else? Well, you see, we know that if two rows or columns of a matrix are the same, then that determinant is 0. So if I write here x1, I should get 0, right? If two of them are the same, we get 0. This means what? This means that x2, so if x1 and x2 are the same, then determinant, this is a polynomial, and it is 0. Let me call this determinant f of x1, xn. This is a polynomial, homogeneous polynomial, and so f of this is 0. Well, let me write it this way. F of x1, x1, x3, xn is 0. Actually, if any two variables are the same, it means those columns are the same, but in that case, volume is 0, right? Yani n boyutlu bir şeye n-1 boyuta indirmiş oluyorsunuz. O yüzden de volume 0. Bu ne demek? This means x2 minus x1 divides this polynomial. x2 minus x1. Değil mi? Yani şöyle düşünün. If f of 3 is equal to 0, this means, and if f is a polynomial, then you say what? X minus 3 divides this f of x, right? So if x1, if these are the same, you get 0. It means this polynomial should divide this. Polynomial. Yani şöyle diyorum. When I plug this, you get 0. This means that this polynomial should be written like this. x2 minus x1 times some other polynomial. So that when I plug x2 equals x1, you get 0. Okay, but this is true for all choices of xi and xj's. Sadece x1, x2, x2 değil. Değil mi? 2 ile 3 de olur, 3 ile 5 de olur. Right? Whenever two variables are the same, you get 0. So indeed, in any xi minus xj should divide f of x1 xn. Değil mi? Çünkü xi ile xj birbirine eşitse 0 olacak. Burada tabii cebirsel bir şey kullanıyoruz. We are using an algebraic fact. What's that? Polynomial rings are unique factorization domains. This is something you haven't seen maybe. So it's you will see it in abstract algebra, which tells us the following. Polynomials are like integers in that sense. They have irreducible elements, and any polynomial can be written as a product of these irreducible elements. And since if I plug xi equals xj, I get 0. This implies that this gadget divides this gadget. Therefore, all these gadgets should divide this. But how many terms do I have? Well, this is true for all I different than j. So I can do the following. Yani x1 eksi 2000 bölüyor. x1 minus x3 divide this. But these are distinct irreducible elements. Therefore, their product also divides this. So x1 minus x2 times x1 minus x3 also divides this. And these are all different factors. Therefore, all of them, the product of all of them should divide this. This means what? This product, xi minus xj, let's say I greater than j, should divide them. But what is the degree of this guy? Yani şu yüzden yapıyorum. x1 eksi x3 ile x3 eksi x1 aynı şey benim için. Birisi diğerinin eksilisi. Yani bu bölüyor, bu bölüyor. Bunun çarpımı da bölüyor dememem lazım. Bunlar çünkü aynı polinomlar. Farklı polinomlar seçmek için şey yapıyorum. Bir indeksi büyük olsun diyorum. Tamam mı? These are all different irreducible factors. They all divide f, therefore their product divides this. What is the degree of this? How many terms do we have? Its degree is how much? Kaç tane terim var? And choose 2. So n times n minus 1 over 2. Well, this product, whatever it is, it has the same degree as this one. So these are two polynomials of the same degree, and one of them divides the other one. This means that f is just some number times this gadget. Değil mi? Bir sayı kadar. O sayıyı da nasıl bulursunuz? Bir tanesinde denersiniz. You just check this number is, I guess, 1. You can see this. Yok. I büyükse, if I is larger than j, it is 1. Nasıl yaparsanız bir tanesinde deneyin. 2'ye 2'de deniyor. Bir de 3'e 3'te deneyin. Hani eksiye dönüyor mu diye. O kadar yeter. Tamam mı? You just try, I mean, on one of them. So, let's say that. 1, x1, 1, what is the determinant? x2 minus x1. O yüzden hani bunu gizlidir. Yani bir sayıyı da bir de şeyde deneyin. 1, 1, 1, x1, x1 kare, x2, x2 kare, x. Yani bir de şeye bakmak lazım. Hani çift boyut, tek boyut fark ediyor mu? Hiç question? Ha, evet. Var mı zamanı? 2 dakika söyleyeyim. Çok hoş bir program. Well, it's an elementary fact. If you have a polygonal region like this, and let's say another region like this, if they have the same area, if the areas are the same, then you can do the following. You can cut one of them along some lines. You can cut one of them along some lines and re-glue them, and you can obtain the other one. Yani elinizde 2 tane, if you have 2 polygonal regions like this, you can just cut one of them along some lines and then re-glue them, and you can obtain the other one. This is an old fact, probably known for many, for a very long time. Hilbert asked the same question for 3-dimensional objects. Take a cube and then a tetrahedron, a regular tetrahedron. Suppose that they have the same volume. They have the same volume. Can we do the same thing? Just divide this cube by cutting along some planes and re-glue them and obtain this tetrahedron. Is it possible? The answer is no. And Max then proved this using something like this. I'm not sure whether what I will write is his original proof, but at least he gave something similar to that. I hope. I think. And then he defined an invariant which doesn't change under cutting and re-gluing operations. What is that invariant? Whenever you are given an object like this, he measures this side length. Let's say this has length E1, this has length E2, E3, E4, and so on. And then whenever he takes an edge, he'll get 2 faces meeting along this edge. For example, this edge is the edge where this face and the bottom meets. He measures the angle between them and he multiplies them. How? So length of E1 and then measure of the angle between these 2 faces. What's that? Pi root 2. But he doesn't take direct, he doesn't take the product, he takes tangent. Okay? And he does this for all edges. How many edges do we have? 12, right? 12 edges. And for all edges, these angles are the same. He computes the same thing for this one. He gets something. And then he shows that this expression doesn't change if you make, for example, cut this and then re-glue. Mesela kestiğiniz zaman niye değişiyor?
Bunun üzerine operasyon. Operasyon.
Evet. If you think about it, if you, for example, cut this like this along a plane, düşünün şöyle, hani peynir kalıbı gibi düşünün, bıçakla kestiniz. Şurada bir angle oluştu. Diyelim ki burası 110 derece, 120 derece, burası da 60 derece. Ama ve ne yaptınız? Kestiğiniz zaman ekstra şu edge'i eklediniz ve 2 tane de açı eklediniz. Şu ekstra edge F bir 120 var. Yani pi over 3. Bir de f 2 pi over 3. So you can add this and you get 2 pi. And actually he does the following thing. Pi. Evet. Sonra da diyor ki o. Pi ise yani bunlar birleştiğinde 180 dereceyse aslında orada h yok, değil mi? So actually, if you add this two, h disappears. So you have to cancel integer multiples of pi. And what he does, you write it as a real number, but he says that this real number is an element of this. Integer multiple of pi are equated to 0. So he considers integer multiples of pi as 0. Yani şurada düşünüyorum. So he considers this gadget. R cancel R over Z pi. Z times pi. But you know, working on an object like this is difficult. He wants to convert them to a vector space without losing much information. And what he does, instead of letting integer multiples of pi to 0, he says it's okay if I let rational multiples of pi 0. And here you don't want this gadget jump over here. You don't want to lose information. So he only lets rational numbers to move to the other side. So he considers this thing and this thing as Q vector spaces. Why vector spaces? Yani vector space şu yüzden istiyor. Vector space almazsa transferlerle işlem yapmanız çok zor. Herhangi bir link üzerinde. Vector space yapmak için de RL'de yapamazsın. RL yaparsan o zaman information'ı kaybeder. Yani şöyle yapırsa bu gibi buraya olacağın için information. O yüzden sadece rasyonelden istiyor. Bir vektör uzayı üzerinde bu tensor'da yazılmış. Oradan da cevabı buluyor.
Yani çok fazla şey yaptı. Bu birkaç aya gitmişti ben.
Bilmiyorum ya, hocası sonuçta bunu şey diye sormuş.
Böyle soru